We will be solving question number 41 of Chemical Engineering GATE 2022 paper, and the subject is heat transfer. The question is, two large parallel planar walls are maintained at 100 Kelvin and 500 Kelvin. Parallel radiation shields are to be installed between the two walls. Assume that the emissivity of walls and shields are equal. If the melting temperature of the shield is 100 Kelvin, the maximum number of shields the maximum number of shields that can be installed between the walls are. The related course material can be found in this link. So here we have been given two planar walls. Okay, so let's just call it as wall 1. This is my wall 2. This is at 100 Kelvin and this is at 500 Kelvin. Now if I want to write the heat exchange occurring between these two walls, I can write it as Q12 is equal to sigma T1 raised to 4 minus of T2 raised to 4 upon 1 plus epsilon 1 plus epsilon 1 upon epsilon 2 minus of 1. So epsilon 1 and epsilon 2 are the emissivities of this wall, and in this case we have been given as epsilon 1 is equal to epsilon 2. Okay, so if we put it into this equation, we will be getting it as T1 raised to 4 upon T2 raised to 4 upon T epsilon 1 minus 1. Now what they are asking is, now they are asking us to put the shields in between this, and the maximum T melting temperature of those shield maximum melting temperature is 900 Kelvin. So how many such shields we can put in between these two planar walls, that we have to find. So if I put this shield between any of these two planar walls, then the net heat exchange will decrease by a factor of n plus 1 as shown in this equation, where n is the number of shields. Okay, so let's say if I am adding one single shield in between them, let's say 3. So I can write the heat as Q is equal to sigma T1 raised to 4 minus of T3 raised to 4. Okay. Now in this case, T3 I will be taking it as 900 Kelvin because that is the maximum temperature I can afford, or else my material will melt. And since we are just adding a single shield, it will become this. We will be dividing it by a factor of n plus 1, and since n equal to 1, it will become now here the values we have been provided as T1 is 1000 Kelvin, T2 is 500 Kelvin, and T3 is 900 Kelvin. Okay, so I will be equating these two terms, and then we will be finding the value of maximum n plus 1. Okay, so let's just write sigma T1 is 1000 raised to 4 minus 500 raised to 4. Now here we don't know how many shields have been provided, so we'll just keep that factor as n. And the maximum temperature that we can afford is 900 Kelvin. So upon n plus 1. Okay, so all these terms will get cancelled out. So this n plus 1 will be 1000 raised to 4 minus 900 raised to 4. If you will solve this, calculate this, then this will come around 2.72. That implies n is equal to 1.72. So now we have to consider a whole number. So that is n should be equal to 1 shield. So if I increase the number of n, let's say if n equal to 2, then my T3 will be greater than 900. In this case, my shield will melt. So that is why we will be taking a number less on the lesser side. So that is n equal to 1 will be the maximum number of shields that can be installed between the walls. Yes, the final answer is 1.